Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject, like, share, subscribe for daily learning videos.
So now we will work on problem 46 from chapter 21. This problem here asks us to write the balanced chemical equation for hydrocarbon combustion reactions, and it gives us 3 different hydrocarbons. So let's go ahead and work on part A, where we have a butane molecule, so CH3, CH2, CH2CH3, and then that's going to react, that's a gas, which is going to react with O2, also a gas, to form water and carbon dioxide. So I'm going to go ahead and leave the spaces here for the coefficients. Every phase here in all of these problems will be gaseous. Okay, so now the main thing that we want to do is we want to make sure that we understand that we're balancing atoms, and also we want to make sure that we have whole numbers for the coefficients. So let's go ahead and show an example of, we see on the left side we have 4 carbons. So we could go ahead and say that we need 4 carbon dioxides to balance these 4 carbons. So if we do that, then we need to balance, we need to calculate the water based on the amount of hydrogens in the hydrocarbon. And we can see that we have 3 plus 2 plus 2 plus 3, which is 10 hydrogen atoms. So we could write a coefficient of 5 for a water. So then we can calculate on the right side the total number of oxygen that we have, which is 8 from carbon dioxide, 2 times 4, and 5 from water, which gives us a total of 13, which means that we would have to have a coefficient of 6.5 or 13 over 2. And that just won't work. That just won't work because we need to have a whole number. So that's not possible. So we erase that and then we continue on. So what we need to realize is that we need to double. First, we need to add a 2 over here. So that gives us a total of 8 carbons on the left side. And then, which would mean we need to have 8 carbon dioxides. So then if we calculate the amount of hydrogen that we have on the left, initially we had 10 hydrogens, but when we multiply by 2, we get 20. So that means we now need 10 water molecules. So then we can calculate how much oxygen we need to produce this amount of H2O and CO2. So the total number of oxygen atoms on the right-hand side is 2 times 8, which is 16, plus 10, which is 26. So if we do 26 divided by 2, that means we need 13 oxygen molecules here. So our coefficients are 2, 13, 10, and 8. So that this gives us the balanced chemical equation. So we can go ahead and move to part B, which is a reaction of an alkene with oxygen. So we have CH2, double bond, CH3 plus oxygen gives us water and carbon dioxide. So again, we first want to calculate the number of carbons we have. So we have three carbons on this side, which means if we put a 3 here, we'll get 3 carbons on this side. But we remember the problem that we had previously with the carbon having an odd number of oxygen atoms. So let's go ahead and double it and put 2 here and put 6 here, which means we need to put 6 here to give us 6 carbons. And then we can calculate the number of hydrogens which we have over here. That is 6 times 2 is 12. And so we look over here, we look over here and we see that to have 12 hydrogens, we need to have 6 water molecules. So a 6 here would give us 12 hydrogens. And then if we look at the number of oxygen first on the right, we can see that we have 6 from water and we have 12 from carbon dioxide. So we have 18 here, which means that we need to have a coefficient of 9 here to give us 18 total oxygen. So we can see again that if we hadn't doubled, if we hadn't added the 2 coefficient to the hydrocarbon, we would have had the same problem where we would have had 9 over 2. But now we simply have 9 and the reaction is balanced. So for part C, we have an alkyne. So we have CH, triple bond, C, CH2, CH3, plus O2, all phases are gas phase, H2O, plus CO2. So once again, we count our carbons. We're going to go ahead and add a coefficient of 2 right away. And we see that we get 8 carbons out of here. We go on to the right and we see that if we add a coefficient of 8 to the carbon dioxide, we will get 8 carbon atoms. We look to the left for number of hydrogen atoms. We can see that we have 6 hydrogens in one molecule, so times 2 is equal to 12. And then if we look at the right, we need to create a coefficient of 6 for water to give 12 hydrogen atoms. And then if we look at oxygen first from the right, we can see that we have 6 from water, 6 oxygens from water, 16 from carbon dioxide for a total of 22. And so on the left, to have a total of 22 oxygen atoms, we need to have 11 oxygen molecules to give us 22 atoms. So our coefficients are 2, 11, 6, and 8.